For number 7, we have a plan to construct an open box from a square piece of material that is 36 inches on a side by cutting equal squares with sides of length x from the corners. So if we do the given for this, we have a diagram over here where we're going to cut these little square boxes out, and each edge of these little boxes has a side x, and that will allow us to fold up along these dashed lines. Oops, not easy to write a dashed line. And that will be the bottom of the box. That dashed line is the bottom. And these little sides, those will be the edges of the box. So the given information is that the sides are 36, and that we're cutting out a box that's x wide. The unknown that we're solving for is we want to write a function v, we want to determine the domain, and then from the graph, so question D is saying determine the graph, from the graph, the maximum volume. So the unknown is the volume, and in particular the maximum volume, and then the dimensions, length, width, and height. The equation for the volume of a box is going to be that the volume is equal to length times width times height. So we need the length, width, and height of the box in order to plug in, because the next step is to substitute. So if we take a look in here, these little pieces, well, each of these widths are x, so the bottom of this box is 36 minus x. And this side as well is 36 minus x. So and the height of the box is going to be this height x. Those are going to fold up, so the height will be x. So we'll end up with a box that looks like this. And the two edges will be 36 minus x, and the height will be x. And you'll have to tape the corners because they'll go just right together when they fold up. So the substitute into the equation would be volume equals length, 36 minus x, times width, 36 minus x, times height. That's the equation that we want to find a maximum for. So that's the equation that we have to type into the calculator, looking at the fact that the y value is the y and the x value is the width of that little box. So in our calculator, we're going to type this equation. We don't even need to FOIL it out. It is going to be a cubic function because there's going to be an x times an x times an x in this function. So we'll put that in our calculator and we'll see if we can find a max of something. Now, in terms of question B, it says determine the domain. So what could x be? Well, we know x can't be 0 because if x is 0, you don't have a box. So in terms of answering the domain, this is what we call the relevant domain. I mentioned this in class. Relevant domain is what are the real values of x, not just the function values, because the function can be negative infinity to infinity. So x would have to be bigger than 0, and x can't be bigger than 18, because if you cut an 18-inch square out of that box, you're going to have nothing left. So we know it's going to be somewhere between 0 and 18. Probably not close to 18. But now let's plug that in your calculator. So if we do 0 to 18 for our x-min and our x-max, that means that we have 0 to 18. And we don't change our y window. Our y window is minus 10 to 10. You don't see anything on your window. So let's think about that equation again. We had y equals 36 minus x times 36 minus x times x. Now, if we're saying that x is going to be between 0 and 18, let's just plug 0 in here. Let's say, what if x is 0? If x was 0, this equation becomes 0. If x was 1, that equation becomes 36 minus 1 is 35 times 35 times 1. So this is a very, very steep parabola. So let's take a look at what that number is. That's going to be 1200 and something. So what that means is that our minus 10 to 10, right, this is going to be 1225. we're going to have to go way up. We're going to have to go up past 1225. So I'm going to put in 5,000 to just see what we get, and then we'll go back and do a zoom fit. But I'm just going to put in 5,000 as our max. So instead of having a Y max of 10, we're going to change this in our window to 1225. We're going to change that to 5,000, okay? And with that new window, with a Y min of minus 10 and a Y max of 5,000, you're going to get a different piece of the graph. And clearly we can now see that, all right, we do have a parabola, and this top of this graph is 5,000. So our max is bigger than 5,000. So you have two choices here. You can either put in another max, you can put some more numbers of x in, or you can just guess a bigger number. Like you can try, well, let's try 8,000 as Y max and see if we can see the top of this curve there. Or you can try a zoom fit. In a zoom fit, if you go under zoom, usually as a zoom fit is the 0 choice. And sometimes it will fit your curve to the part that you want, and sometimes you still have to work with the window settings anyways. So I'm just going to go ahead and plug in 8,000 for my Y max into my window. And now with a max of 8,000, I can definitely see the top, and I've done a calc max, and the calc max occurs at the point 12. So 11.9999998 is 12 for your calculator, comma 6912. So we're going to go back to the question, and the question says, using the graphing calculator, graph the function and sketch it. So we can sketch it in our window. We would say, in the window on your sheet, you would say my Y min is minus 10, Y max is 8,000, my X min is 0, my X max is 18, and I have a maximum value of 12,6912, so that's the volume, the 6,912. So the maximum volume we can have in our box is 6,912, and these were in inches, so that would be cubic inches. And the X, which is going to be the height of the box, right, is going to be 12, and that means that the length is going to be 36 minus 12, and the width is going to be 36 minus 12, and these are all in inches. So that's the answer to this question.